Now I'll keep the source. So where is the source? Source will be here. Not on the axis. It is not on the axis. This is the axis. No? It is not on the axis. So again, all the questions like first, what will happen to pattern? Then how to get order of interference on the axis or at any point. Then what is the shift? Then what happened to number of maximas? All different. So here, the ray emitted by this, first it will move like this. So the ray emitted by this is the ray 1, and the ray 2 look at the rays before slit they have path difference, after slit also they have path difference, so we have to consider both this, then we have to get expression for the path length here. Okay, I'll give all the dimensions. So this is slit S1, slit S1, this is slit S2, distance between slit and screen, distance between slits is S1, S2 is equal to D, vertical separation. Where this and this distance is E, and the source is at a distance L. What are the conditions? D very much less than D. Similarly, A very much less than L. Small d and A will be of order same, millimeter. D and L will be of order meters. So now we have to let at point P, let they undergo interference. So we have to calculate the path difference of the rays arriving here, and this is a screen. Okay, let's proceed. We know something like and all. This will be additional path. It will cover, no? So call this as delta x2, path difference after slits. Come for this. Look at the left side of the slits. S1, S2 are slits, no? This one. On the left side of the slit, which ray will cover more path? The ray 1, arrows, no? So we'll do some. Before slits, which ray will cover more path? Ray 1. So are you seeing the red color is what? Ray 1. Which ray will cover more path before slits? Ray 1. Which ray will cover more path after slits? The ray 2. So this additional path these two need not be parallel. These two lines need not be parallel. These two lines need not be parallel. Let me draw a line. Dotted line not possible. I'll go for one color line itself. Okay, are you seeing clearly? So these two lines are not parallel. Strictly, they're not parallel here. So so this distance is not equal to this one. Then these two yellow color and dotted line, they are not parallel. So this one. So how to, and this will be perpendicular again. This will be the perpendicular. So this additional path the ray 1 will cover before slits. you have to calculate this delta x1 and delta x2. The net path difference is what? Shall I add up both or shall I take difference? I have to take difference. Delta x2 minus delta x1. It should be. How to calculate delta x1, delta x2? This, the mathematics already, what we know is like this is theta and this distance is d. Here also I'll put same dotted line. Okay, let's proceed from here. This will be theta. This will be the angle made by the, so again look at the condition. What is A very much less than L, no? So because of this, in the diagram it appears A and L are of same dimension, but A will be of very much less than L. So if you look at the practically, so the conditions will be this will be slit S1, S2. So what is the angle made by both the rays S1, S2 with horizontal? Will be same, will be equal. From that, what happen? I should derive a formula here. Okay, how to derive that formula? So I'll take help of this. So this will be this angle made by the ray here will be, let me call that as phi. This will be 90 minus phi. This will be phi. Or I'll take alpha something. And use some color. Let it be, say, alpha. This angle will be alpha. I'll arrange this delta x1. I'll write it. This distance will be delta x1. This angle, let me call alpha. If this is alpha, this should be the alpha. This should be the alpha. Even the angle made by this should be the alpha. This not needed. Will I agree this? What is the condition for this? Why I have to draw like this? Because the A very much less than L, no? One problem, if you can understand this one problem, you can manage, because where the source is not there on the axis. The reason for this, why we assume the thing like this. So this alpha, this will be 90 minus alpha. This is 90 here. This is M, this is N. This will be 90. At N, angle will be 90. So this angle will be 90 minus alpha. This one. So this should be 90. So this will be alpha. Okay, from this, so can we calculate now what is sin, like a delta x1, delta x2. So the net path difference, I'll write the equation. Keeping that equation, looking at the diagram, I'm going to write all the equations now. Okay, let me proceed like this. So the net path difference will be delta x net is equal to delta x2 minus delta x1. Why delta x2 minus delta x1? Because the ray 2 will cover more path after slits and the ray 1 will cover more path before slits. So I should take the difference in the path difference. So delta x2 already from geometry we know. Directly I write it as dy by capital D. Delta x1 how to calculate is what I'll take help of this delta x1. So let me do calculation, I'll come for this. So sine alpha equal to delta x1 by d. So what is delta x1? D sine alpha. As A very much less than L, sine alpha, we can write tan alpha. So delta x1 equal to d tan alpha. Now look at this triangle. S, let me call this is O. Take this A. From the triangle OAS. So what is tan alpha? You can write it as A by N. So and what is delta x2? Delta x2 you can write from here this particular thing. This will be theta, no? So sine theta equal to delta x2 by d sine theta. The condition d very much less than d. Sine theta will become tan theta. So substituting this, tan theta delta x2 equal to d tan theta, or dy by capital D. Let me substitute all the values. So the net path difference is equal to dy by capital D minus dA by N. We are searching for maximas. So therefore this should be n lambda equal to dy max by capital D minus dA by N. So what is y max is equal to? No. N lambda capital D by small d plus A capital D by ND. Anybody, what will happen to pattern? Will it shift upward or downward? We have to look at this equation and we have to conclude. Pattern, I'll bring the equation. Pattern will shift, as pattern will shift upward. Put n equal to 0, where the central maxima will be. First, I'll start with YCM. For n equal to 0, YCM, I'll get the position of this one. For n equal to 0, I'll get not center of mass, central maxima. YCM is equal to A capital D by L small d. I got positive. So therefore, where the central maxima will be above the axis. So the total pattern now will shift upward. If the source lies below the axis, pattern will shift upward again. So the central maxima will be somewhere here. We don't know exact upward to slit S1. So this is the location of central maxima. The next other things, higher order interference, no, 1, 2, 3, n equal to 1, n equal to 2, 3. Not n equal to 4 will be, I'm just roughly I'm showing that one. Maximas will be like this. So this is the axis. So if the source lies below the axis, the pattern, the central maxima will lie above the axis. Again, the same mathematics will follow. What is the order of interference at the axis? So what shall I do? Put y equal to 0, then you get order of interference at the axis. To calculate order of interference at the axis. So I should put y equal to 0, no, at axis. What is the order of interference? So at axis, order of interference y will be 0. Y equal to 0. So 0 equal to n axis lambda capital D plus A capital D by small d minus A. This will be N.
Small d y.
The small
Y
d will
max.
not be there. Small d. Lambda will be there. This will be order of interference at the axis. It depends on AL, the ratio of A by L, and this lambda. Capital D, small d here will cancel out. So what order of interference will be there at the axis? No, you can ask like a in anywhere, see anywhere on the screen, opposite to slit S1, put y equal to plus d by 2. Opposite to lower slit S2, put y equal to minus d by 2. So like this, if this source lies below the axis, you have to use this formula. I think in exam you don't get this much of time to draw a diagram. Straight away you must know the formula here. In exams you have to straight away you should write this formula. I'm making things clear. For exam you should well prepared. You should begin with this formula. If slab comes, I'll tell you what has to be done.
Order of interference small d by L lambda.
Ah, yeah, that one. Order of interference, number of maximas. That's all.
At the axis, it should be small d by L lambda. You missed d.
Small d, capital D will cancel out.
No, sir, small d will be present at the numerator.
D should not be there in YCM, sir.
Okay, I'll check it. I'll check it. YCM. I'll check the equation. Expression for y max, no? Y max will be okay. Small d will not be there here, no? I'll make correction. Okay, fine. Yeah. Y max equal to n lambda capital D by small d is a plus. It will be a capital D. Here one small d will not be there. Okay. Then YCM will be a capital D small d. Next, order of interference. So here one, this D will not be there, no? Okay, now fine, check it. I think, okay, yeah. Yeah. Just all of you make correction. Those who took screenshot, no, you delete it and go for new fresh one. Huh? Okay, now come for what happened to number of maximas. I'm still saying that d by lambda only. It will not depend on position of source. This is very important. You move the source below the axis, above the axis. That will not determine number of maximas. The number of maximas depends on the ratio of the distance between the slits and the wavelength. Well, it depends on the distance capital D between slit and screen. No. Practically, you can justify, or what happened from mathematics only, you can just show that. Because theta, like suppose say number of maximas are 5. What do you mean by that? Central maxima, not in this case. Not in this case. If the source is on the axis, I'm just saying that one. So if number of maximas are 5 means what happens? Central maxima will be the right axis. Then 5 maximas you have to put it. When will the fifth maxima? Theta equal to pi by 2 at far away. That's what we mean to say here. Okay, now if the source is moved below the axis, number of maximas will remain same. This I'm making things very clear. Okay, now I want to bring the pattern down. Source, let it be there only. I want to shift the central maxima then. I want to bring the pattern down in such a way that central maxima should be there at the axis. What shall I do for this? Go back to the slab concept. To shift the pattern up, what you should do? You should put slab at upper slit. To shift the pattern down, what you should do? You have to bring the slab, you have to put the slab at lower slit. So now the central maxima should be brought back to the axis. So what shall I do now? So I should now put a slab at the lower slit. So I just asking you now what should be the thickness of that slab. I'm continuing this. This concept is not over. To bring the pattern back to the lower slit. To bring the pattern back to bring the central maxima at the axis. So what should be the thickness of slab I should place and where I should place? This will be the question. So next year, in the above discussion, in the above problem, if the central maxima, if the central maxima has to be shifted to the axis. What to do? Don't move the source, huh? But what to do is what the question mark we are introducing. So let's see that what conditions will arise here. All of you. So I'm just starting with this particular question. From the above discussion only we are proceeding. So where the source? The source was somewhere here. The source was here. So a ray 1 and this will be the ray 2. Ray 1 will cover this much of path. Okay, this is the path covered by the rays like this. So let me indicate clearly. S1, this S2. Now where I should bring this slab? I should put the slab at lower slit. The slab should be kept at the lower slit. Okay, all of you. So these are the slab is placed such that it will pass normally. That I'm unable to show in the diagram. So what should be the thickness of that slab? And the refractive index, let it be. Are able to see all of you? I brought why the slab should be at lower slit. We know that if a slab is placed at lower slit, the pattern will shift downward, such that the central maxima where it should lie, it should axis. This is a condition given for us, such that the central maxima should come at the axis. Okay, for that, now we'll discuss the cases. This is n equal to 0. The source is here. The same dimensions. We didn't change anything. So again, the mathematics, from the mathematics, it will be theta, call this is alpha. This alpha, this theta. You recollect back the mathematics what we discussed. From that only I am directly write. Let me write it. And now you just be careful. Again, the writing that path equation is very important. So what is the best way, like how to proceed? Delta x net is equal to. So don't jump to writing formula directly. Better follow the procedure here. So what is the procedure? What it says that F2P. So everywhere it is A. And what is the lambda? Lambda is the wavelength of light in here. This is a monochromatic source. No, S2P. What is the thickness of slab? Minus T. It will cover some path, some length. It will traverse in the slab, and optical path length will be mu T. Minus S1P. This is everything after slits. Before slits, then we will cover more path after slits, the ray 2. We'll cover more path after the ray 1. So that it should be and right delta x1. So it should be mu. delta x1 directly we know, shall I write it as dA by small l, like previous what we discussed. S2p minus SP. This is what path difference due to geometry will become delta x2. This is what you can write dy by capital D. But what was the condition that was asked? The central maxima should come where? Should be here. The central maxima should come here. That was the condition given. No? So what should be the value of y here for that to happen? Y should be 0. Y should be 0. And what is delta x net? At central maxima, what will happen to the net path difference of the rays arriving there? Should be 0, no? So I'm going to write this is 0, d by capital D, this will be 0, mu minus 1t. So what is the thickness of the slab? D by dA by 1 mu minus 1. This should be the thickness of slab. L it is. Is it okay? No. So again, the priority. Everyone should put effort in writing such equations, because rest all mathematics we can manage. This is the before slits. So it's shall I put in simple way? You want to shift the pattern down, put slab at lower slit. You want to shift the pattern up, put the slab at upper slit. That's all. Over. So this should be the thickness of slab to bring that one. What actually happened? So you may find little bit difficult, or you could, if you could have used some common sense instead of so much of mathematics. That same thing. You could have proceeded like this. The same discussion I'll continue. So this was our source, no? Yes. So the ray 1 will go like this, because we are discussing at central maxima to be at axis, no? So bring the ray here. The next, the ray 2, it will pass through this. This is a ray 1. This is a ray 2. Clear this. So this is a path difference. It will be having here. Call delta x1. What are the path difference due to slab? The slab is here, no? Okay, so now see things here. This actually you could have thought in this way, and you could have avoided some mathematics. So to save time, you can analyze like this also. Nothing wrong. This distance is what? E. This distance is L, and S1, S2 is equal to the conditions given. I think it's quite clear, no? The path difference, which ray will cover more path before slits? Ray 1. Which ray will cover more path after slits? Ray 2. So therefore, I should increase the path length of the ray 2, no? So therefore, what I'm doing is I'm bringing a slab in the path of the ray 2. So that will see that if the path difference what the ray 1 has gained before slits that much of path, additional path. If the ray 2 gains after slits, then the net path difference of the rays are having here will be 0, and we do get here central maxima. Means now you can ask questions. So central maxima can I shift wherever I want? Yes, you can do adjustment in such a way that central maxima you can shift wherever you want. I think this will be much easier to know what the path difference. So this the total mathematics should be delta x1 should be equal to path difference offered due to the slab. So what is delta x1? Delta x1 will be dA by L. This should be equal to mu minus 1 into T, where T is the thickness of slab. Got this? So this is one simplified way of doing things. If they ask you something, anything more, no, you come for the first method. But the objective question, I think, comes no, you can wind up like this only in a very simple way. I'll just take you to the first discussion what we made. Okay, that yellow color what I shaded, you know, so this will be very important. Almost every numerical, the same procedure is what I'm following, you see. Okay, the same thing, just we are discussing only central maxima. Now I'll ask you a question. I want central maxima exactly opposite to slit S1. What shall I do here? I want here central maxima here at this particular point. What shall I do for that? It's not that at axis only. Here come for this. We wanted central maxima to be at axis, no? To be at axis. That's why the y we have put it 0. If I want central maxima opposite to slit S1, what I should do? Y I should write it as d by 2. Y I should write it as d by 2. And what should be the value of n? N should be equal to 0, that one. Then I should solve for this. The same problem. I'll copy this because I need this. Well, I'll continue from here. We have already one diagram. Now, what is the next condition? The next condition such that the source is here. And this will be the ray 1. This will be the ray 2. The same thing. A strict condition, the central maxima should be exactly opposite to slit S2. It should be brought here. So for that, what condition? What has to be done? This is a slit S1, capital D. This will be lambda D. This is source, and this is A. Okay, now we'll proceed like this. So the medium surrounding everything, let it be A. What is delta x? So we'll proceed with the formula. So I need a slab. I will take help of a slab. With the help of a slab, I'm going to pull down the pattern. So definitely what happened? The central maxima was somewhere above. So you can ask question, how do I come to know that where I should put a slab? I think you have to be alert. In the very first initial case, where central maxima is here, I think you have to be extra careful. Huh? I'll take you back. It's not like some blind way you can proceed here. If I think this was the diagram, no? Come for this. If central maxima, all of you just look at this one. If central maxima lies above S1, if it were somewhere here in this calculation, I just put it here. If it were somewhere here, then what when I should pull it down, no? So where I should put a slab, I should put a slab here at the lower slit. If the central magma were lying below S1 in the diagram, so where I should put a slab? If I put slab at lower slit, what happened to pattern? Will shift further down, no? So is it okay now? So where central maxima is there in this diagram? It all depends on the values. Sir. I just made a guess here. The value of A, small d, capital D, and the value, all those 5 values will determine where central maxima or the position of central maxima, YCM. So this YCM, we have equation. So YCM what means A, capital DL. This will determine if the central maxima is above the slit S1, then you have to put slab at lower slit to pull it down. The central maxima lies below the slit S1. To bring it exactly to opposite slit S1, what happens? You have to put slab at upper slit. You do have problems of these kind of where a student has to be alert. Unless you don't locate exact position of YCM, means is it YCM greater than d by 2 or less than d by 2? I think that matters. So now what we have to do is I'll just proceed with the mathematics. The same thing I'm continuing, some different case I took here. So this should be n lambda, you write it, dy by capital D, mu minus 1, t minus d by. So for the location of central maxima, put n equal to 0, d, and we want exactly at d by 2, opposite slit S1, mu minus 1 t. I'm just assuming that the slit is what I'm putting. Just I'm making a guess. You have to really verify the problem. Huh? The complete problem we have to change. I'm just assuming that the central magma is above, but in a slab at a lower slit. I'm just giving rough idea. Okay, now calculate the width of the slit from here, thickness of the slab. Solve this, we'll get this one. So this will be T is equal to dAl mu minus 1 minus d square by 2 mu minus 1. Okay, fine. So this is the one way of asking questions for you. Why should be plus d by 2? Because you wanted upper slit. So this should be that value here. Now similarly